Hello everyone, it's Sammy Ayo with SAA Services. We're going to talk about welding and my welding shop, welding fabrication, modifications, and repairs. As usual, I'm going to start this video off with a safety moment. And in this video, we want to talk about safety glasses. There are multiple styles of safety glasses. You got your plain, clear safety glasses. You got your fancy little blue tinted safety glasses. These are clear they have bifocal lenses in them. You can see the bifocals in the corner on both sides. And you also have the same thing with dark glasses. These are dark glasses. Again, these have bifocals on the inside corners. Hopefully you can see those bifocals down there. I think these are probably rated around 1.25 or 1.50. As I always say, safety is first, especially in a heavy industrial environment. And you can't do anything without your eyes. You got to be able to see to do anything, especially mechanical. If you're doing actual mechanic work, you got to be able to see the parts you're taking on and taking off. If you're doing welding, you got to be able to see. If you're doing mechanical installations, you got to be able to see. So that's imperative that we protect our eyes, and we also have to make sure we have the correct equipment to do it with. Now, on right here, this is a wrapper that one of the pair of glasses came in, and you'll see right here it says Z87. That is the standard by which all safety glasses being used in a heavy industrial environment should be at. On every one of these pairs of glasses, when they were new, most of these glasses are kind of old. I don't use many of them anymore, but I keep them around the shop just for backup. But usually you'll find either on the corner of your lens or inside the arm of your eye arm, somewhere on these glasses, you will usually see Z87. On these particular ones, I found it just inside the arm. You're probably not going to be able to see this in that video, but just inside that arm, I'm trying to hold it the right way, where you can see it, it says Z87 in there. So that's what I wanted to share with you all in this video is safety glasses, eye protection, and make sure that Z87 standard. It's Sammy Ayo with SAA Services and Welding Shop. So today we are modifying my friend Scott Daniels' boat. He bought this recently, well, I say recently, a few months ago, and he brought it to me, and he wants to make, as usual, Scott's got to make a bunch of modifications. That's Scott, and that's one of the reasons why we love him. So anyway, let me show you where we're starting out at, okay? Scott came to me several months ago and wanted this visor on the front of the boat removed. Well, guess what? It is removed. But my buddy Scott, as always, now he wants it back on. But the problem is he can't see the bow of the boat. The bow of the boat right here from the driver's seat with the visor where it was originally at. So what I told Scott we're going to do is, on that line, we're going to cut that visor down halfway, and then we're going to move it back. So the original location was approximately there. That was the original location, approximately there. I'm going to slide this back a little bit further and show you. You can see where I cut it. whenever I cut it before where the welds was at, you can see where I cut it. So what we're going to do now is, I got marks here. We worked on this last night some, and I have marks here, and so we're going to cut it in half, lower it, and bring it back to that location so that when we're finished, it'll be half as tall, moved back, and hopefully he'll be able to see over the visor and see the bow of the boat right here while he's driving. This is our main project. Along with that, the roll bars used to be mounted at that location. Let me back up a little bit so you can see better. So we're going to move the roll bars up to approximately that location. So that, for one thing, and one of the main things is, he could not open the engine compartment all the way before. He wants to be able to open the engine compartment all the way back. He could not do that with the location of the roll bar before, because further back, they would interfere. When you raise that lid, the engine compartment would hit the roll bar up there. So we're going to move it forward, and also he and the passenger will also be able to use the roll bar also as a grab handle. That's another project. And the last, or one of the last projects, I don't think that we'll ever have any last projects on Scott's stuff. The other project is, we're going to take the stern of the boat, the keel of the boat, and we're going to extend it out even with that step up to protect his. This is a jet driven boat. We're going to extend the keel of the boat out even with that to protect his jet drive. So this is our project, and I will try to keep you all posted as best as I can while we're working on this, on how it is going. These boats are made overseas somewhere. A guy in Walker, Louisiana built this particular one off of plans, and to our knowledge, there's only 6 of them in the state of Louisiana, and I'm sorry, 6 in the United States. Only one. This is the only one in the state of Louisiana, and we're going to make it Scott's custom design when we're finished. Okay, so we got a line laid out all the way around here, all the way around the other side. And what I'm going to do is, I'm going to use my Eastwood VersaCut 60 plasma cutter to cut his visor down to our desired height. I'm going to cut it a little bit long, so that when we go to actually put it on the boat, as you can see, there's a few little highs and lows, but I'm going to cut it a little bit long so that I can work this visor into those highs and lows. When they welded this boat, Most of the weld was done with GTAW, which is gas tungsten arc welding. Aluminum, usually do, well, you always weld aluminum AC. We're going to be on AC with my machine, alternating current. And you do AC, GTAW with high frequency. What high frequency does is it allows you to strike an arc without having to actually touch the metal, because when you touch the metal with aluminum, it makes a big mess immediately. But when they originally welded this, I'm trying to get where you can see it, they did a GTAW weld right along here, all the way around. They welded this plate to this pipe. Well, when they grounded it down real thin, so we got us a hairline fracture here. So what we're going to do is I'm going to take my machine, GTAW, TIG, high frequency, remote amperage control, AC, and I am going to repair that hairline fracture and sand it down and try not to take out so much metal like they did to where it'll crack again like that. So I'm going to use an 1/8 inch 53-56 GTAW TIG welding rod. For those who don't know the difference between a welding rod, excuse me, a welding rod and a welding electrode. An electrode is used for SMAW, stick welding. Okay, that is an electrode. There's electricity going through that electrode to the weld and the base metal. This is a welding rod. There's no electricity going through this. My TIG torch is going to produce the electricity. The tungsten on a TIG torch is your electrode. I'll show you that in a second. That's your electrode. Your electricity is going through that to create your arc and your weld puddle. All I'm going to do with this is fill the area that I want to weld. This is just a filler rod. That is the difference between a welding rod and a welding electrode. A welding electrode produces electricity. A welding rod is only a filler. That's it. This is a TIG torch. The electricity comes from my welding machine, which is set on, again, AC, alternating current. I'm going to use remote amperage control and a high frequency to start, because again, I don't want to touch my electrode. This is my electrode. This is called a tungsten, and this is my electrode. I place the tungsten inside my TIG torch, and I barely want, I want that TIG, for aluminum welding high frequency and remote amperage control, I want my tungsten to barely, almost not stick out at all, just almost like flush. And then that's where I want my tungsten, my electrode for TIG welding aluminum on high frequency. The reason I'm using high frequency is, again, I don't want to touch the electrode to the metal. It'll make a mess on aluminum. High frequency will let it strike an arc without actually having to touch. If I was welding metal or pipe or anything else except for aluminum, I would have my machine set on, instead of AC, it would be on direct current, straight polarity, and I would have my tungsten sticking out probably about 3/8 of an inch, and then I would you can still use high frequency, but most people don't. But it would be on direct current. It would not be on alternating current. That's the reason this tungsten balls up, is because it is on alternating current, meaning that the current is going both directions. So the tungsten goes from positive to negative, in milliseconds. And every time it becomes positive, it balls that tungsten up a little bit. When you weld in direct current, the tungsten is always negative and it never balls up. It keeps a point on it. And in future videos, I'll try to show you that and explain that. So this is my remote amperage control foot pedal. And what it does is I can control, I have my machine preset on AC. Get that way y'all can see that AC. I have my range selector from 20 amps to 230 amps, it looks like. And I have it, this needle doesn't point very well, but I have it at about, I don't know, 85. That would be more or less a percent. That's not really, I guess you'd say percentage, because you really remote, I'm going to control it with my remote amperage. So I'm going to TIG weld this GTAW using remote amperage control. With aluminum, it's really important that you can control your amperage, because it's going to, whenever I start welding here, I want to start out fairly warm, then get a little bit hotter and hotter and hotter, and then when I get near the end of this crack, I'm going to ease off on my amperage. I'm going to try to video this so you all can watch what I'm doing.
So I'm just heating that metal up and dipping my TIG rod in there and filling that gap. That's all welding really is. I'm using electricity to combine two pieces of material together and using the filler metal to fill it in with. And that's all we're doing here. I had to reposition. And when I get through with this, I'll blend it back in again. But I'll not remove as much metal as what they did when they originally built this. I'm just dipping rod, dipping rod, dipping rod. In a minute I'll show you the dime.
I got to reposition one more time.
And that about fills that crack up.
And that is it. So I have successfully closed that crack up. Look how pretty. They call them dimes, stacking those dimes. That's not the prettiest work I can do. I was a little out of position trying to get this videoed, but it still came out very good considering that's the first time I've made that kind of weld in, man, probably a couple of years. Maybe a year or so. So we now have Scott's visor tacked on to his boat. It's just tack welded on for now. I'm going to let him come over here and take a look at it the next day or so before I weld it out. Make sure he's satisfied with it. It's a lot easier to cut now than if I welded it on there. Sorry for my view. I'm stepping around my welding machine here. I should have moved out the way already. But anyway, his visor's tacked on, and I'm going to let him inspect it before I finish welding it out and make sure he's satisfied with it. So now I'm going to go back here to the transom on the keel, and he wants to extend that keel out to we decided 13 inches, even with the, about even with the back of that step up there. So that's what I'm fixing to work on now and get it all tacked in place. Let them come take a look at that and inspect that also before I go any further. I have his hull extension on, and it's welded out and completed, but the only little concern we have is this corner could flex some. So what we're going to do is I'm going to come in here and I'm going to put a gusset in from here straight down, and it's going to come into about right here, and it's going to support this. And we may have a little bit of flex on that corner, but it's not very likely, and it certainly won't be noticeable. So I am fixing to put that in there. So now we got the gussets welded on to the hull extension, and that thing's not going anywhere. So we got Scott's boat welded and modified the way he wanted it. I dropped the ball a little bit on this video because I really wish I would have actually walked around the boat and showed you all in detail more the modifications that we made. But Scott left here with it late the evening we worked on it, which was this past Monday. I think today is Friday, April the 17th or 18th, something like that. Anyway, we finished it up this past Monday evening late, and everybody was ready to go home. So I still wish I would have videoed some in the boat in more detail and showed you all in more detail what we modified. But at the end of the day, I think I showed you all pretty well what we was going to do. We accomplished all of that and then some. Scott was extremely happy with it, and he's got 1,000 more ideas that he wants to do to it. So as we do those, I'll do my best to make sure we capture those in more videos. So in the meantime, I hope you all enjoyed my video. I hope it was informative. I hope you all learned some stuff from it. I hope it's something that's going to be possibly useful to you in the future. And if any of that is true, or all of it's true, please, by all means, subscribe, like, and share my channel, and spread the word for me. Thank you all, and you all have a wonderful, blessed day.